So let us now discuss problem number 2. Design the torsional reinforcement for the rectangular section shown in the figure. So, didesign natin yung reinforcement ng beam natin given, which has a value of F'C which is equal to 30 megapascal, Fy which is equal to 420 megapascal, the value of your Vu which is equal to 160 kilonewton, the value of Tu which is equal to 10 kilonewton meter, and the area of our steel bars is equals to 1,000 mm squared. Covering of 40 mm. So, yung covering natin from the face of your stirrups. So, ating stirrups natin, yung shaded portion. So, from the face of your stirrups to the outermost fiber of your beam, that is 40 mm. So, sa lahat, yung clear spacing ng ng stirrups natin from the face of the stirrup to the outermost fiber, 40. So, ang 40 dito, 40 dito, 40 doon, at saka 40 din sa taas. And 65 mm centroidal reinforcement to the outermost fiber. So, from the centroid of your steel bars to the outermost fiber, you have a concrete cover of 65 mm. So, ngayon is isosolve natin yung torsional reinforcement ng beam natin. So, for this one, siyempre, hanapin muna natin yung value ng effective depth natin, which is denoted by small d. Sir, paano po natin isosolve yan? So, that is 500 minus 65. So, you will have an effective depth of 435 mm. And after we calculate for the value of your effective depth, siyempre, we're going to check muna if torsional reinforcement is required. So, sir, paano po natin i-check kung kailangan po ba yung torsional reinforcement or hindi? So, we will going to follow yung sinasabi sa code. So, we will going to compare the value of your actual TU to the given value natin dito sa threshold torsion. So, tawag natin dito is threshold torsion. So, pagko-compare natin yung mga values natin na yan. By the way, when we talk about VU at saka yung TU, automatically, naka-ultimate na yan. So, meaning to say, factored na yung mga loads natin dito. And in computing for the value of your VU, same lang yung application natin dun sa pagkuha natin ng value ng VU dun sa shear na diniscuss natin last time, na kinukuha natin yung VU at a certain distance D, nagka-cut tayo dun sa beam natin at a distance of D from the face of your support. And from that section, kinukuha natin yung value ng shear, which is yung VU natin. And yung TU, ganun din naman yung principle natin. Kumukuha mismo tayo dun sa critical section. So, let's go back to the formula. So, eto nyan. Yung magkakaroon lang tayo ng problema dito is what will be the value of your ACP and the value of your PCP. Sir, paano po natin kukunin yon? So, kunin lang natin siya. So, we have ACP. That will be the area. So, we have a base of 300 and a height of 500. So, ACP is now equal to 150,000 mm squared. How about the PCP naman? That is the perimeter. So, meron tayong dalawang 300 plus dalawang 500. So, you have a value of your PCP which is equal to 1,600 mm. So, for this one, meron na tayong value ng area at saka perimeter. We will just substitute yung mga values natin to the given formula. So, we have a value of your reduction factor na 0.75. Assume normal weight na 1.0. Square root of F'C na 13 over 12 over yung ACP natin, that is 150. So, i-square natin yan over PCP natin na 1,600. So, you will have a value of your threshold torsion which is equal to 4.814 kilonewton meter. So, for this one, meron tayong given na TU which is equal to 10. And eting 10 natin, kung i-compare natin yan, 10 is greater than, or TU is greater than the threshold torsion, So meaning to say, torsional reinforcement is required. So after nating ma-check kung kailangan ba talaga yung torsional reinforcement or hindi, for the next step, we will going to check for crashing of concrete. Sir, bakit po natin sine-check yung crashing of concrete natin? So we are checking that to check the adequacy of our section. Kung kakayanin ba nung section natin to withstand the given torsion. And of course, para to solve for that, we will going to use a certain formula here. So gagamit tayo ng mga pagko-compare natin yung mga actual values natin to the resisting moment. So we will now solve the adequacy of our section. Kung kakayanin ba niyang dalhin yung torsion natin. So for this one, ito yung formula natin. So if this value is less than to the value of this, so meaning to say adequate yung section natin or kakayanin niyang dalhin yung given torsion. So sir, what is the principle of this of these conditions? So ito lang naman. So kung interpret natin yung mga formulas natin. So, since eto naka-VU tayo, yung VU natin, that is in terms of Newton. Diba? Tapos, yung MM natin, naka-MM naman yung BW, naka-MM yung D. So, meaning to say, naka-MM squared tayo. MM multiplied by MM, you have MM squared. So, meaning to say, stress eto, at the same time, stress din to kasi eto, TU, tsaka yung pH natin, AU, AOH, naka-squared pa. So, mangyayari dito is that will become Newton MM squared. Same with this one. Yung VC natin, naka-Newton. Yung BWD natin, that is an area. So, that is MM squared. Ito din, naka-megapascal din tayo dito. So, meaning to say, etong pinagko-compare nating mga values, these are all stresses. So, yung una natin dito is etong part na to. This is what we call ultimate. But sinabing ultimate, sir, kasi nga yung subscript natin is U, meaning to say, naka-factor na yung loads natin dyan. So this is our ultimate shearing stress. And eto naman yung susunod nating values. Since meron tayong torsion dito, eto naman yung ultimate torsional stress. And yung nasa kabila naman, kung mapapansin natin dito, this is what we call yung ultimate stress natin. So kung babalikan natin yung shear in beams, so eto lang naman yung yung VU natin. So mapapansin dito, VU is equals to P VC plus VN. VS, V sub S. Wherein yung VC natin, kung gagawin natin siyang stress, it will divide lang natin yung area natin na BWD para maging stress. Plus, etong VS natin, yung maximum ng VS natin that is 0.66 square root of F prime C BWD. Wherein, yung 2/3 natin, that is equivalent to 0.66. So, matatandaan natin yung VS kapag nag-greater than siya dun sa value ng maximum natin na value, which is 0.66 square root of F prime C BWD, i-adapt na lang natin spacing ng shear reinforcement is yung S max natin. So yung 0.66 na yon, so kung ipa-fraction natin, that is 2/3. So again, yung principle lang naman ng adequacy natin, checking inadequacy, we're going to compare yung applied natin. Ito yung applied versus yung resisting. So yung resisting natin, that will be the capacity of your beam to resist these applied loads. So sir, paano po natin i-compute ngayon yan? Okay. So dealing with pagkuha ng natin, AOH natin, at saka yung pH natin. Kasi ito lang naman yung bago sa paningin natin. What will be the value of your pH and what will be the value of your AOH? So, ginagawa natin yan, kinukuha natin yan dun sa center to center ng stirrups natin. So, for this one, kunin natin yung width from the center of your stirrups reinforcement, and then center ng stirrups. So, this will be your X. Yung value natin dyan, this is X. Same with, eto, kunin natin, center of the stirrups. Dun sa center sa stirrups naman sa taas. So, kunin natin yung value ni Y naman. Sir, paano po natin yan kukunin? So, the value of your X, simple lang naman yan. So, that is yung kabuuan natin, which is 300. Minus, meron tayong clear concrete cover na 40 sa kabila, 40 dun sa kabila. So, you have 80. Minus. So, dito meron tayong kalahati ng stirrups, that is 5. Tapos, dun sa kabila din, kalahati ng stirrups na 5. So, minus 10. So, the value of your X will now equal to 210. How about the value of your Y? So, that will be yung total depth natin na 500 minus clear concrete cover 40 minus clear concrete cover 40. So, you have minus 80 minus kalahati ng stirrups 5 plus kalahati ng stirrups 5. So, you have 10. So, the value of your Y, which is now equal to 410. And paano naman natin kukunin yung AOH natin? So, for this one, AOH. So, that will be 210 multiplied by 410. So, AOH is now equal to 86,100 mm squared. And yung piece of H naman natin, so twice lang natin yung 210, plus twice natin yung 410, kukunin lang natin yung perimeter niya. So, you will have a value of 1,240 mm. After calculating for the value of your AOH at saka yung value ng piece of H natin, masasolve na natin yung applied stress natin, at mako-compare na natin siya dun sa resisting stress natin. So let us now compare yung applied stress natin versus the resisting stress. So bago natin makuha yung mga yan, kailangan pala natin yung value ng V sub C natin. Since wala naman sinabi sa problem kung detailed or simplified yung calculation natin, let us choose yung simplified calculation natin na 0.17 lambda squared of F prime C BWD. So you have 0.17. So we have a normal weight concrete square root of yung F prime C natin na 30 megapascal multiplied by BW, which is yung 300. Again, yung BW natin, that is always perpendicular sa shear natin. Wherein yung direction ng shear natin is pababa. And we have an effective depth of 435. So the value of your VC in kilonewton, we have 121.512 kilonewton. So meron tayong value ng VC natin. We can now calculate etong nasa formulas natin. So for this one, unahin muna natin etong sa applied natin. So we have yung VU natin. So yung VU natin, ito yung given natin sa problem natin na 160 kilonewton. So gagawin natin yung kilonewton, kaya times 10 raised to 3 over yung BW natin na 300 multiplied by yung D natin na 435. So i-square natin yan plus yung sa torsional ultimate stress natin. So we have a value of your TU na 10 kilonewton meter, gawin natin siyang Newton mm multiplied by yung pH natin na 1240 over 1.7, yung AOH natin na 86,100. So i-square natin yan. So yung value ng applied natin is now equal to 1.57 megapascal. And we're going to compare this value to the value ng ultimate stress natin. So for this one, yung value niya will be 0.75. Yung given na VC natin, we have 121.512 times 10 raised to 3 Newton over yung area natin na 300 multiplied by 435 plus 2/3 of square root of f prime c. So we have 30. So this is in terms of megapascal. So sa mga formulas natin, I stand corrected, wala pala to, no? Yung BWD natin. So wala yung BWD natin dito sa resisting natin. So we have a value which is equal to 3 point. Ito yung capacity nung natin, nung beam natin to resist yung applied stresses natin. So we have 3.437 megapascal. Since 1.57 is less than to the value ng 3.437, therefore, section is adequate. So since adequate naman section natin, no need to increase the beam height, we can now proceed in calculating for the value of your transverse reinforcement. So after we check the adequacy of our section, we will now solve for the spacing of our transverse reinforcement. So kapag sinabi natin transverse reinforcement, so we are talking about, di ba, yung placement ng mga natin, ng mga shear reinforcements natin. So what will be the spacing ng transverse reinforcement natin? So given, meron tayo ditong area total daw, that is equal to 80 over S plus AV over 2S. So when we talk about 80 over S, eto lang naman yung sa torsion natin. Kaya nga tinawag dito combined shear and torsion. So, to reinforce in transverse, kapag nakahilera yung mga stirrups natin, pagsama na lang natin yung reinforcement ng shear at saka yung torsion. So, yung una dito is para sa torsion. Yung susunod naman para sa shear naman. So, for this one, let's compute first for the value of your 80 over S. So, 80 over S, sir, what will be the formula for that? So, we have T over N, or yung nominal torsion natin, over 2 AO FYP cotangent theta. So for this one, what will be the value of your AO? So AO, this is equal to 0.85 of AOH. So meron tayo ditong 0.85. Yung area natin, that is 86,100. So the value of your AO is now equal to 73,185 mm squared. The value of your theta, that is equal to 45 degrees. And the value of your nominal torsion, that is yung ultimate torsion multiplied by yung reduction factor natin. So yung TU natin, that is 10, divided by yung reduction factor natin na 0.75 since NSCP 2015 yung ginagamit natin. So we will have 13.33 kilonewton meter. So this is mm squared. So after nating makuha yan, so etong theta natin, no, for non-precess lang to ha, that is 45 degrees. So kung isa-substitute natin yung mga values natin, so you have na Tn, that is 13.33. So naka-kilonewton meter tayo, times 10 raised to 6 para maging newton, mm. So 2 multiplied by, yung AO natin ha, that is always 85% of AOH. Yung AOH natin, yung na-compute natin kanina. So we have a value of 73,185 mm squared multiplied by the value of your FYP. So dito, yung given lang natin is 420 megapascal multiplied by the cotangent of 45 degrees. So the value of your 80 over S is now equal to 0.217 mm squared per millimeter. After we compute for the value of your AT over S, let's compute naman for the value of your AV over S. So sir, paano po natin kinukuha yung AV over S? So, ang babalikan natin yung mga formulas natin dun sa shear in beams, di ba? That is S is equals to AV Fy D over Vs. So, dito ayusin lang natin. So, mangyayari, palitan lang natin yon. We have Vs over Fy TD. Okay. So, let's compute now for the value of your AV over S. So, dito naman kailangan natin munang malaman yung value ng Vs natin. So, ang babalikan natin, Vu is equals to P Vc plus Vs. Wherein, kung aayusin natin yan, Vs is now equal to Vu over P minus the value of your Vc. So, meron tayong value dito ng Vu natin na 160 over 0.75 kasi NSCP 2015 minus yung VC natin na na-compute natin kanina na 121.51. So, you have a value of your Vs which is equal to 91.82 kilonewton. So, after we calculate for the value of the V sub S, makukuha na ngayon natin yung value ng AV over S natin. So, what will be the value? So, yung Vs natin, that is 91.82 times 10 raised to 3 para maging Newton over. So, yung FYT natin na given na 420 megapascal multiplied by 435 which is the effective depth of your beam. So, AV over S, we have a value of 0.503 millimeters squared per millimeter. After that, nakuha na natin yung AT over S, nakuha na natin yung AV over S, na pag-combine na natin yung shear at saka yung torsion. Let us now calculate for the total area. So, yung AT natin over S, that is 0.217 plus kalahati daw ng AV over S. So, we have 0.503. Naka-over 2 pa tayo dito ha. I-divide pa natin yan by 2. So, you will have a value of 0.469 mm squared per mm. Ngayon naman is how we will going to calculate for the value of your spacing. E di gawin natin yung total natin na area, i-divide natin yan. So, baliktad. So, yung area ng isang bakal natin na gagamitin, i-divide natin yan sa total area. Sir, bakit po baliktad? Kasi kung titingnan natin dito, eto. So, this is yung ano natin, area over sa spacing natin. Sa spacing, naka-mm tayo, mm squared per mm. So, para mm na lang yung matira, so, gagawin natin is i-divide natin yung AB natin by the value of your total area. So, let's say, gagamitin natin bakal is 10, kasi that is the diameter ng given natin. 10 mm. And then yung total area natin, that is 0.469 mm squared per mm. O, eto niyan, yung magiging unit niya is mm squared. So, mangyayari is makakancel out lang. Si mm squared matitira is millimeter. So, you will have a value of 167.46 mm. Kaso nga lang, sa pagkuha ng spacing dapat, round down tayo. Wala dapat butal. So, we have 160 mm. So, after natin makalculate yung value ng spacing natin, so, i-compare pa natin yan to the value ng S-max natin, which is yung PH over 8 or 300 mm. So, you have a value of your PH. Yun yung kanina na perimeter from the center of your stirrups. So, you have 1,240. That is the value of your PH divided by 8. So, you have a value of 155. So, round down natin yan to the nearest tens. That is 150 mm or yung 300. So, from this, meron tayong tatlong pagpipilian na spacing. 160, 150, or 300. Therefore, we will going to use spacing na lowest, which is 150 mm on center. So this will be your answer dun sa traverse reinforcement natin. So sir, paano po naman natin isosolve yung longitudinal reinforcement natin? So that is our next step. Nasolve na natin yung traverse reinforcement o yung mga stirrups natin. Lastly naman is yung mga longitudinal. So when we pertain about longitudinal, etong mga bakal natin na na supports the torsion, and at the same time, yung mga bakal na supporting naman yung bending naman natin. So for this one, hanapin natin yung mga bakal natin along the longitudinal axis. So let's solve for longitudinal reinforcement. So for this, para ma-solve natin yan, so kailangan muna nating pag-compare muna yung nakuha natin dun sa torsion na 80/S to the value of 0.175 BW/FYT. So itong FYT natin, that is 420, pero usually nagbibigay yung problem kapag sinabi sa problem na FYT, yun yung gagamitin natin. Kaso nga lang wala naman sinabi sa problem, so pagtiyagaan na lang natin yung FY. So we have 0.175 multiplied by BW na 300/FYT na 420. You have a value of 0.125. So kung compare natin yan sa 80/S natin na 0.217, that is greater than. So meaning to say, nag-satisfy yung values natin. So okay. So we can proceed to our next step. So next naman is, let us compute for the value of your area of longitudinal steel. So hanapin natin yung area of longitudinal steel. So ito yung total area ng longitudinal steel bars natin, denoted by A sub L. So sir, what will be the formula for that? So A sub L, that is simply equal to PH multiplied by yung 80/S na na-compute natin kanina, multiplied by Fy sub T/Fy, multiplied by cotangent squared theta. So you have a value of your pH na 1,240, multiplied by yung 80/S natin na 0.217. Yung FYT natin, since wala namang given, assume na lang natin na parehas siya ng Fy over yung Fy natin na 420, cotangent squared, so we have 45 here. So the value of your area of longitudinal steel is now equal to 269.08 mm squared. So kung meron tayo dito na area na compute, i-compare natin yan to the value ng AL minimum natin. So ipag-compare natin yung dalawa. So again, i-compare natin yung nakuha natin na value ng area of longitudinal steel to the value of your minimum area. So sir, what will be the formula? So as illustrated dito sa board natin, this will be your formula. So kung mapapansin natin dito, itong formula natin on the second term, which is ito, parehas lang naman sila ng format nito. pH, ito yung pH, yung 80/S, yung FYT, parehas lang naman sila. And then yung cotangent squared theta natin. This is cotangent squared 45. So this is equal to 1. So meaning to say, pwede natin sabihin na this is the value of your AL. As long as for non-prestress, for non-prestress, pwede tayong mag-shortcut dito. So let us now solve. So find square root of yung F prime C natin, which is given na 30, multiplied by yung ACP natin, that is 150,000, multiplied by 12 yung FY natin na given na 420, minus etong AL natin na 269.08 mm. So meaning to say, the value of your AL minimum is now equal to 545.98 mm squared. Kaso nga lang, eto nga yung AL natin na total, this is the minimum. So, i-adapt natin yung higher value. So, this will govern. Kasi nga yung minimum natin is hanggang ano? Hanggang 545.98. Tapos, yung gagamitin natin is only 269.08. So, adapt natin yung higher value. And then, let's say gagamitin natin dun sa longitudinal steel bars natin is we're going to use 12 mm diameter bars. So, for this one, para makuha natin kung ilang piraso ng bakal yung gagamitin natin, so we have yung total area natin na 545.98 mm squared over area ng isang bakal. So you have a number of pieces of 4.83. So kung i-round up natin yan, that is 5 pieces of 12 mm diameters. Kaso nga lang, meron lang tayong problema dito, no? Dealing with longitudinal reinforcement bars. Ito yung note natin dyan. Number of torsional bars are always even. So, even lagi yung numbers natin. So, kung meron tayong 5, paano natin yan i-lay out? So, mangyayari niyan is maglalagay tayo ng 4 dito. So, meron tayo dito ng 4. 1, 2, 3, tapos 4. And then, kailangan even yan dito sa gitna. So, ilalagay na lang natin yung additional natin dito sa ilalim natin. So, yung pang-5 natin, ilalagay na lang natin siya, isasama na lang natin siya sa main bars. So, for this one, since 5 yan, eto yan. So, etong part na to, kailangan even lagi dito ha. And at the same time, etong part na to, is isasama na lang natin siya sa mga main bars natin to resist yung bending. And at the same time, since nandyan naman siya, is i-resist niya rin yung torsional natin. So, for this one, kailangan lagi na i-layout natin dito sa gitna talaga. Dapat, pag dinivide natin yan, is parehas yung even nila. Even yung number of reinforcement natin for torsion ha. That's why ilalagay natin yan sa main bars para hindi na lang siya magulo dito sa bandang gitna. So, ilalagay natin ngayon, eto yan, yung mga naka-X natin na legend. So, eto. Yung naka-X natin na legend doon, that will be sa main bars natin. Iko-combine natin yung isang reinforcement natin na 12 mm diameter na longitudinal bars with flexural reinforcement or yung sa mga main bars natin to resist bending. So, mangyayari niyan is meron tayong value ng bottom bars. Therefore, yung bottom bars natin, kanina yung bottom bars daw natin, meron siyang total area na 1,000 mm squared. Kaso nga lang, since dinagdagan natin siya ng isang bakal, so you have pi over 4 na merong diameter na 12 mm squared, 12 mm, so you have a value of your area which is equal to 1113.97 mm squared, 0.97 mm squared. So, ganun lang yung principle natin dealing with reinforcement sa torsion.